A second here, I'll get a close-up on it. A Triplett model 1210A. I got it at an estate sale. It's just more of a conversation piece than anything else, but it does test tubes, and I'll show it to you right now. Like I say, it's a Triplett model 1210A. I already have a tube in it. It's a number 35 tube. This tester here, I'm estimating in the 1930s. It's a metal case. I got the literature off the internet. And the setup for a number 35 tube. The load is 39. Filament volts is 2.5. And the selector's in the number 1 position. Load is 39. We're not splitting hairs here, but 39. Position number 1 on the selector. Very important here, the 2.5 volts on the filament. It's a very crude setup here. Well, my bad eyesight, I mistaken this for 2.5, and I blew a tube out. I got very bad eyesight, and I have to depend on the lens to zoom in and see it, and I'm looking at it with reading glasses, and I thought that was 2.5. So I blew out a tube before I did this video. That's not very good for somebody who's been working around this stuff for more years than he cares to count. Anyways, we're about to test it, but before we do, we're going to flip the switch to line check. Line check is right here. This is the line check selector here. If I was to move it into any other position, you'll see that she'll drop, see? So you need to be up into here for the workshop here. In this shop here, I'm getting about 120, 121 volts. Okay, now we're going to test the tube, so we're going to flip it down to test. The meter goes to 0. The tube is already in and warmed up, so we're going to push what they call a value. It's a simple emission tester. We're going to push that, and there we are. Now, if you wanted to verify as to what the load does, hold down the emission and move the load control just a little bit, and you'll see that as you drop the numbers of the load down on this particular tester, it'll drop the emission down. A lot of testers, if you increase the load, it'll drop the emission down. So it's really just a reference point, and it calls for 39, so we're setting at 39. You're pushing here. Now normally you do not do this, but this tube was tested good in my Hickok 550X tester, which is a little newer, and it's a mutual conductance tester. So we know it doesn't have any shorts, but we're going to check and see what this thing shows up as shorts. So in order to do that, if you look on the tube selector, as I said, we have it in position 1. But in order to check for shorts, we still leave it in the test in this position here. And I don't see a short indicator on here. So I'm going to move this switch. Okay, the short indicator, it helps to read the instructions, will show up. If I rotate this control, you can see where it says shorts right here. Okay. If I rotate this like this, alright, if there's any shorts in it, it should give a needle deflection. And it isn't given a needle deflection. We'll put this back into 1. Push the value again, and we're testing good. We will remove the tube and show you a little bit of the tester here. It's a metal box all the way around, and so I have the schematic that's in this little pamphlet here. And of course it lists tubes that need a tube adapter in order to check, which I do not have. But I thought it would be an interesting little piece to show you. And for antique radio testing, if even you get some of these old emission testers that are even a lot newer than this, they'll be sufficient. The most important thing you want to do on a tube is to make sure it doesn't have a short. Do not try to test a tube in a tube tester until you have checked for shorts. As I told you, this tube here that I just got through testing was already tested for shorts in another tube tester, so I knew it was okay. So I hope that helps you a little bit. A little interest in going back in time on old-fashioned tube testers. We'll be having more, so be on the lookout for more videos coming up in the future. Thank you.